2.3 Differentiation Rules. When we talk about differentiating, dy dx is a noun. It is the derivative of y with respect to x. D dx, that's an action. It's a verb. It means you have to take the derivative. So when you see something written like this, it means take the derivative of, in this case, c. Okay, this means the derivative is, and then whatever it happens to be. So the first rule we have is the constant rule. It's really simple. Think about how the slope of a constant function changes. It doesn't. So it's always 0. So if we find the derivative, and I'm going to write dy dx equals 0. Okay? F prime of x, 0. S prime of t, 0. And remember, pi squared is a constant, k is a constant. And this time I'm going to write this, y prime, 0. Any constant function, the derivative is going to be 0. Now we have the power rule. This is going to be extremely helpful. If you have something written in this form, then the derivative is this, okay? So if we have f prime of x here, all you do is you take your exponent, 3 times 2, you get 6, and then you subtract 1 from the power. Okay, this one looks a little bit tougher because it's not written as nicely. Let's see if we could rewrite it. And that is the 1/3 power. So then our derivative, we multiply 1/3 times 1/3. Whoops. Let me get my pen back. Come on. All right. 1/3 times 1/3, that's 1/9. X, subtract 1 from the power, negative 2/3. You could leave it like that, or you can rewrite it in the original form, which is one of the most common. So we have 9, and then x squared, the whole quantity cube root. Okay, same thing with this. If you rewrite it, it might make it a little bit easier. We have 5/3 x to the negative pi. So dy dx, the derivative of y with respect to x, would be negative 5 pi over 3 x to the negative pi minus 1. Looks ugly, but it's not so bad. And then again, you can rewrite that as a fraction if you want. That would be negative 5 pi 3 x to the, if we take a negative out, we get pi plus 1. Or you could just leave it in that original form. And then the last one, again, rewriting is going to be very helpful for you. We have 6x to the negative 3 over 5 dy dx. We have negative 18 fifths, negative 3 fifths times 6, x to the negative 8 fifths. And there you go. That's the power rule. It's pretty simple, and it's going to be very helpful. Moving on to example 3. We're going to find each of the following. I'm just going to rewrite it a little bit. Okay, f prime of negative 1. Well, first let's find f prime of x. 4 times 1/2 is 2. X to the subtract 1 from the power, 3. Now f prime of negative 1. Plug in negative 1, and you get negative 2. F prime of 0. Plug in 0, 0. Now we're trying to find the x-coordinate where f has a slope of 128. Remember, derivative means slope, so I'll put that in for f prime of x. And we need to find the x-coordinate. Okay, divide that by 2. And we would get x equals 4. All right, moving on. Find the equation of the tangent line at x equals negative 2. We know we need two things. We need a point and a slope. So let's find f of negative 2. Plug that in, get 12. Now we need a slope, so we might as well find our slope function, 6x. Okay, so f prime of negative 2 is negative 12. So our equation, and I like to write it in Taylor form. You can write it in another form if you'd like. Y equals 12. Then we have our slope of negative 12 times x minus negative 2, or x plus 2. Okay, the next part, find the equation of the normal line at x equals negative 2. Our point's still going to be the same, but now our slope, we'll just write slope, is the opposite reciprocal of what we used before. Come on. 1 over 12. So then we have y equals 12 plus 1/12, again, x plus 2. A little bit of fun now. Find the points, okay, x and y coordinate, where the normal line intersects the graph of f of x equals 3x squared. So here's our normal line equation. And we want to know where that intersects the graph. All right, I'm going to expand this. And I'm sure all of you love fractions, but in case you don't, let's just multiply everything by 12. All right, if we move everything to one side, we can solve this maybe by factoring or completing the square. Okay, so I want you to go ahead and do that and put that in your whisk. You should have 2 points. Remember, it said find the point, so I need an x coordinate and I need a y coordinate. For each of there should be 2 answers here, 2 unique answers. All right, and then the last thing is just we're going to do a little bit of rewriting just to use the power rule. Right now, the way it looks, can't really use the power rule, but if we rewrite it, right, we could rewrite it as 5/2 x to the negative square root of 2. Now when we take the derivative, we multiply 5/2 times negative square root of 2, x, and then subtract 1 from the power. It's pretty simple. Okay, rewrite this. So I would have 4 over 2 cubed, it's 8x cubed. So then I could also write that as 1 over 2 x to the negative 3. Take the derivative now, negative 3/2 x to the negative 4. And if you want to rewrite it, you'd get negative 3 over 2x to the 4th, if you want, or you leave it. Okay, the next one. We don't know how to work with fractions or when we have terms in the top and the bottom, so you got to think about this as t to the 1st over t to the 1/2. Okay, that's the same as t to the 1/2. So then we have 7/3 t to the 1/2. Take the derivative, 7 over 6 t to the negative 1/2. If you want to rewrite it, you can for your answer, or not. It's fine. And lastly, we can rewrite this one. Negative 2, that means move it to the top. So we have 6 times 3m squared. And notice last one we had d dt, d dm. We're just saying what variable we're taking the derivative with respect to. So we have 3 squared is 9. That'll give us 54m squared. To take the derivative, we do 2 times 54, 108. M, 2 minus 1 is 1. All right, that's it for this video.